This conference
Amen.
will now be recorded.
Oh, give thanks to the Lord, for he is good, his love endures forever. Heavenly Father and Mother, we praise and thank you for this pleasant evening. Thank you for bringing us together for the very beautiful purpose of this international conference. As we are in the moment of valedictory function, bless all of us, bless all the participants, bless all the resource persons, principal, and all the faculty, whoever involved in this very noble cause from morning up to now. May all the efforts taken by each of them be blessed. May your guiding spirit be upon them. Bless them with wisdom and knowledge that whatever they intend to do may be blessed by you and by your inspiration and wisdom only. Be with all of us that we may enjoy this moment of this valedictory function. We make this prayer through Christ our Lord. Amen. Our Father who art in heaven, hallowed be thy name. Thy kingdom come, thy will be done on earth as it is in heaven. Give us this day our daily bread. Forgive us our trespasses, as we forgive those who trespass against us. And lead us not into temptation, but deliver us from evil. Amen. In the name
Thank you, sister. It is a moment of extreme pleasure to welcome each one of you. To welcome you all, I call upon Dr. Sujata Anand, the principal of Loyola Institute of Technology.
Thank you, Angel. Today was a wonderful day, and the wonderful day has culminated in the valedictory session of today. Team Loyola has been working under the able leadership of Mr. Ganesh Narayanasamy of IBM for months together, and today was made possible purely by the grace of God. On behalf of our beloved founder father, Reverend Father J.E. Arulraj, all the sisters of DMI, the fathers of MMI, our correspondent, Reverend Sister Teresa, our administrator, Reverend Sister Selvi, it's a pleasure to welcome all of you to the valedictory ceremony of the International Conference on Emerging Trends in Artificial Intelligence for Industry 4.0. We have two very special people with us today, and it's my duty to welcome both of them. First, I welcome Mr. Ander Ochow, Cognitive Computer Lead, IBM Europe, and Mr. Ganesh Narayanasamy, Open Power Leader in Education and Research, IBM Systems. We are waiting to listen to you to all that is happening in the industry, sirs. And it is a pleasure that you have taken some time off to honor us with your presence. Welcome. I now welcome Mr. Dhyaneshwaran, Public Health Organization, Singapore, Mr. Satish, Senior Pipeline Engineer, ADNOC, Abu Dhabi, Dr. Belsam, Professor SRM, for taking time to be with us throughout the day, session sharing the various tracks of the department and sharing so much of technology with the participants. The day was made beautiful by all your presence, and welcome all of you to this conference which has been hosted by Loyola Institute of Technology. I take the opportunity to welcome Dr. Leo Vigilis, Deputy Director, DMI Group of Colleges, and I welcome all the participants who made this day possible. I also welcome the staff members of Loyola Institute of Technology and all our beloved students without whose hard work this day would just have not been possible. So welcome all of you, and I'm not going to take much more time, and we are waiting to listen to our distinguished guests. Thank you.
That's a pleasing welcome to what I know is going to be a great conference. Thank you, ma'am. Before we move on, I request the following participants to turn on your videos so that we could click a happy picture. Correspondent, Reverend Sister Teresa, our principal, Dr. Sujata Anand, our vice principal, Dr. Nalini Joseph, head of all the departments, Mr. Ander, Mr. Narayanan, our coordinators, Mrs. Kumada and Mrs. Indumati. Thank you all. And with that, we come to a very interesting part of the day. We have with us a very well-known speaker, Mr. Ander. I now request Mrs. Indumati from the Department of Electronics and Communication Engineering to introduce our keynote speaker.
Thank you, Angeline. It's my pleasure to introduce our invited speaker, Mr. Ander Ochao, Cognitive Systems Architect and Team Leader at IBM Madrid, Spain. He is in association with IBM since 2000. He did his bachelor's in computer science and engineering and did his master's in financial economy at Comillas Pontifical University. He worked as a lecturer of computer science in the same university for 4 years. Later, he shifted his career as an IT industrialist and worked in various positions and had a progressive growth. To name a few, he worked in Panda Software International, Televent Housing, ETS Solution Architect, Z-Growth Solutions Architect, SPGI, Power and AIX. He also have a rich working experience as a client technical professional at IBM Smart Cities. In the last 2 years, he turned his attention to the artificial intelligence and now is fully focused on IBM Power AI and all the AI ecosystem at IBM. Currently, he is the leader of Cognitive Systems group of SPGI with a group of fantastic professionals. His top skills are AIX, virtualization, SAN. He has many certifications to his credit. Some of them are SAP HANA on Power Systems, IBM Certified Solution Advisor, Cloud Computing Architecture V5, IBM Power Systems, Power 9, and IBM Virtual Collaborator. He has a good number of publications in reputed journals. I really seem it a great honor to have such a knowledgeable person with a diverse experience is present with us. I strongly hope his talk will give a lot of insights about artificial intelligence, machine learning, deep learning, and IBM AI Supercomputer for healthcare too. I once again wholeheartedly welcome you for this international virtual conference on emerging trends of artificial intelligence in Industry 4.0. Thank you. I welcome you, sir. Over to you, Angeline.
Thank you very much for your kind words.
So having heard the powerful words from ma'am, I'm sure all the participants can't wait to hear from you, sir. The floor is yours.
Okay, thank you very much. So I think that somebody has to make me a presenter to be able to share my screen.
Yes, sir. Yes, sir. I'll just make you just a minute, sir.
Okay.
Yeah, we made, sir. So you're in mute. You're in mute, sir. You can just share your screen now. You're in mute.
And are you able to share your screen?
So just a minute, we'll just make you a presenter, sir. Just a minute. I think you had some network issues. So now you can share your screen, sir.
Okay, I will try. Sorry, 1 second. My operative system has to make some changes to the configuration to be able to share the screen.
Yeah, okay, sir. We'll just wait.
Yeah, I will have to restart the application again. Just 1 second, please.
Yeah, okay, sir. Okay.
Dear participants, thanks a lot for waiting so patiently. Just a few more seconds and Mr. Rando will get back to us. Thank you for your patience. Just a few more seconds.
Yay,
And can you unmute?
Sir, now I have made you as a presenter. You can share your screen, sir. And you are in mute.
காலையில சொன்னேன் போடுன்னு சொல்லி போன் எடுக்க மாட்டேன்
எவன் அடிக்கிறேன்
அவனுக்கு
Okay.
Mute, sir. We could not hear your voice.
கோடத்தின் ஓப்பன் இல்லையா?
Okay, I think I was experiencing some problems with the application, but it looks like it may be working now. I'm going to try to share my screen.
And if you are not able to share your screen, just talk about it, and probably you can share with me the screen, or the organizer can move the screen too. Please do that quickly, whatever is convenient for you.
Can you hear me?
Yeah, I can hear you. And
okay, perfect. So I cannot see anything, because the application is hung. However, if you can put the
yeah, you just start your presentation, and
okay.
I will do the necessary things.
Okay, I
No
just
problem.
shared the presentation
Yeah,
with you by.
I got that. I'll take care of that.
Okay, so let's go to the first slide. I'm sorry for all the technical problems, but my computer looks like a bit slow today. Thank you very much for the kind introduction. As I said, my name is Ander Ochoa. I'm Cognitive Systems Architect, right? Meaning that I mainly work in the south of Europe, in Spain, Portugal, Greece, and Israel. I'm also Open Power Foundation member. And I have been working for IBM since year 2000, so 21 years now. And probably all my professional life, or most of my professional life, I have been working with power architecture. And the idea today was to present you one of the aspects of the artificial intelligence in today's Industry 4.0, because artificial intelligence has become something really, really important. And nowadays, one of the most well-known industries is the healthcare one. The healthcare is, unfortunately, it has become #1 industry for everybody. So let's go to the second slide. I have prepared a small agenda today for talking about some topics which I think are quite interesting to understand. Obviously, I'm going to talk about healthcare industry, but everything that we are going to talk today can be extrapolated to any other type of industry. First of all, we will talk about the relationship between healthcare and IBM, and what has used IBM as a main tool to fight against this COVID-19 thing that we are fighting today. And this is mainly some supercomputers, or the best supercomputers that we have. So we will talk about them. We will talk about the building blocks that they share. We also are going to talk about the unique advantages of those building blocks, because they are really, really good, and they are something that really needs to be talked about and shown, because they offer huge advantages for all industries. Then we are going to make a small summary, and we will talk also not only about hardware, but also about software, because nowadays there is a huge trend worldwide working with containers, and I will show you one example of how IBM in combination with Red Hat is using those containers. And at the end of the presentation, I hope we will have enough time to show a small demo of this software. So without further ado, let's go to slide number 3. We will start talking about IBM and how IBM is helping the healthcare industry to fight against this pandemic. We are fighting against something which is absolutely global. All countries are involved into this. No country can be left behind, because it would be horrible for everyone. So we all have to fight this war. And IBM, watching this, has decided to put into this equation what IBM has done the best in the last years. And this is some of the best IBM supercomputers in the world. So let's go to slide 4. And IBM has created some of the most powerful supercomputers in the world, and has decided to use them to help the healthcare industry to fight against the COVID-19, trying to find drugs, trying to find treatments, trying to help everyone. Obviously, those supercomputers are today located in the US. So mainly the efforts are done from there. But as I said, this is something global. This is something that no country can be left behind. And for example, and let's go to the slide number 5. From the country where I work, which is Spain, IBM has donated the Universitat Pompeu Fabra from Barcelona. We have donated several computers to be used completely for free to this university so they can find solutions for this COVID-19 problem. Also, in the Barcelona Supercomputing Center, which is the most powerful supercomputer in Spain and has been one of the most powerful supercomputers in Europe, also our tools, our hardware, and our software has been used to fight this menace. But those supercomputers, those building blocks, also, they are not only for one unique purpose. I mean, they can be used for anything in the healthcare industry. For example, I'm sorry, but I still cannot share the name of the customers, but I can share what they do. I have one customer that I personally helped with some of those building blocks. This customer is in the public sector. It's dedicated to healthcare. It's in the north of Spain, and they are fighting against rare diseases, those strange diseases that usually the pharmaceutics don't want to be too much involved. Also, I have several customers who are working with genomics. And in particular, we have the Spanish hospital Severo Ochoa, who are doing analysis of protein folding molecular analysis. For those of you who may be in this sector or may be interested in those points, we will share the presentations, of course, and I have added some links so you can dig more in case, as I said, you are interested. So let's go to the next slide, please. And this is slide number 6. The title is IBM and Research and Development. And I wanted to put this slide because it's very important for me. As an IBMer, old IBMer now, I am really proud that my company has been for 28 years in a row the company with more patents in the whole world. This is huge. This is something really important, and this shows our commitment with research and development. And this research and this development, who has created those patents, is what has allowed us to create those supercomputers that we have used against the COVID-19 problem of pandemic. And well, I have been so far talking a lot about supercomputers and so on, but I still haven't shown them. So let's go to slide number 7. And in this slide, you will see how we have 3 supercomputers. In internet, there is something called the top 500 list, which lists the 500 most powerful supercomputers in the world. And this list, we have 3 supercomputers in the 10 first positions. We used to have position number 1 and number 2 from 2018 to 2020, which is a very good achievement, because this list is really dynamic. It changes a lot. But just last year, a new supercomputer from Japan took the position number 1. However, they are still really powerful, and they are the ones who have been used against the COVID-19. Also, in position number 9, we used to have the IBM Marconi 100 from Cineca in northern Italy. I say used because I just checked this morning, and now I think we are in position 11. As I said, this is really dynamic and changes a lot. However, it's really powerful. Let's go to slide number 8. This is the IBM Marconi 100, which is in the north part of Italy. It's very powerful, and it's exactly the same as the Summit and the Sierra. They are exactly the same. However, sorry, the only thing that changes is the number of nodes that they have. The more nodes they have, the more powerful they are. But they share exactly the same components, all of them. and not only Summit, Sierra, and Marconi 100. Also, we have several other examples that I will show you that share exactly the same components. So let's go to slide number 9, please. And we have here the Barcelona Supercomputing Center Mare Nostrum 4. This is a very good example. It's located in the northern part of Spain. And this is the 4th version of this supercomputer. In version number 3, they used to have 30, without N, 30 racks filled with x86 servers, and they were providing 1 petaflop of computing power. Well, now we added just 3 racks of our servers, of our building blocks for those supercomputers, and with 3 racks we added 1.5 petaflops, which is incredible. This is how our technology differs from the regular x86 world. Let's go for the next one. This is slide number 10, and it shows the most powerful supercomputer in the private sector. Okay, the previous ones were in the public sector or linked to the public sector. This is the most powerful supercomputer for a private company, and it's for Total Fina. It's an oil company. It's a French oil company, and well, they do whatever oil companies do to find oil. Also, this shares exactly the same components as the other ones. Let's go for the next one. And this is a very important supercomputer for me. It's in the MIT, and it's not because I have been in MIT. I would love to have been there, but it's important because we helped John Kohn, who is the lead architect for this supercomputer. We helped him to get this supercomputer, and it also, as you can see, it shares exactly the same components. We will talk about the components later. And just let's go for the next slide number 12. This is the last one I wanted to show you. It's located in the UK, and also it shares exactly, again, the same components. And I have repeated the whole time that they share the same components because, as you can see, what IBM has been able to do is to create a de facto standard for the artificial intelligence supercomputers in the world. Because I haven't said it, but they are perfectly suited for artificial intelligence workloads, of course. And well, yes, they share the same components. So let's go to the next slide, and we will talk about those components, those building blocks that they share. So let's go to slide number 14, please. In slide number 14, we can see is one overview of the Summit components, which are exactly the same as all the components in all those supercomputers that we have seen. They share the same connectivity. It's based in Mellanox InfiniBand fabric. They share the same storage, which is based in something called GPFS, or well, I cannot remember the commercial name now. The whole people, we call it GPFS, even if it has changed. I think it's something called spectrum scale. And it allows all the nodes to access the same files or the same components at the same time. So it's really, really powerful. It's based in small servers who share Power 9 CPUs. Those CPUs, they are not x86 CPUs. They are open power-based processors, and those processors have been developed under the Open Power Foundation umbrella. Also, they share NVIDIA V100 GPUs. Okay, those are the GPUs with the G, and they are really, really powerful. So as you can see, with all those components, we have created all those supercomputers. We just have changed the number of nodes that they have. So let's go to slide 15, please. And this is the heart of those components, of those nodes, let's call it this way. Those nodes, they are based in Power 9 processors, and as you can see in this slide, well, they have more power than regular x86 processors. They can move data way faster than x86 can. But what I would like you to take a closer look is at the diagram. Probably this is not the best diagram to show, so let's go to the next slide, slide 16, please. In this diagram, which is exactly the same as the previous one, you can see how we have in the center 2 Power 9 CPUs or sockets, each one with up to 20 cores, and they are linked up in the graphic with one InfiniBand adapter. This is one of the first differences that this architecture has, because this architecture has been created with artificial intelligence in mind. And this shared InfiniBand adapter, which is a unique solution in the whole industry, because usually one adapter is always linked to just one socket, but this one is linked to both sockets at the same time, allows us to share the data in the memory of this server with the data in memory of another servers. So it creates like a unique server linking all those memories. Okay, they use something called RDMA. Also, in the bottom of this diagram, you will see the GPUs, the NVIDIA V100 GPUs, which are linked between them with one NVLink. This NVLink is one bus that was developed by IBM and NVIDIA, and it's very, very fast. It can exchange data at 150 gigabytes per second. But also in our servers, it allows us to communicate between the GPUs and the CPU at the same speed. This is also a unique solution because usually in the x86 servers, they have to use something called PCI Express, which is way slower. It's like 10 times slower. So this quick speed allows us to take also the data in the memory of this server and share it with the data, with the memory in the GPUs. Have it in mind because all the solutions that we are going to talk about now are based in those two unique advantages, okay? And they are unique. No other solution of any other vendor have them. So let's go to slide 17, please. And I'm going to show you now how the software can take advantages of those unique features. First of all, we will talk about large memory support. Then we will talk about distributed deep learning. And then we will talk about a new framework called SnapML. Let's go to slide 18, please. Okay. In this slide, you have a summary of something called large memory support. Sorry, can you? Sorry, Ganesan, can you hear me?
Yeah, I can hear you. Hold on, team.
Okay.
You know, please, you know, go and mute your phone. I mean, mute your computer if you're not talking. Thank you. Andrew, go ahead, please.
Yeah. So we are in slide 18, and I'm going to try to explain what large memory support is. So large memory support is going to take advantage of what we have seen that we can use the memory in the main of the data in the main memory of the node with the memory in the GPUs. We all know that the memory in the GPUs is quite limited. It can be 16 gigs, it could be 48 gigs, it could be, I have seen some ones with up to 80 gigs of RAM, which is quite good. And if we are working with numbers, with figures, it's perfectly good. However, when we are working with images, for example, it could be quite small. So with large memory support, we can use the memory in the main memory, the data in the main memory to feed the GPUs instead of using only the RAM in the GPUs. This allows us to create a GPU, for example, instead of 16 or 32 gigs, it's like if it would have up to 2 terabytes of RAM. So it's a huge advantage. And this allows us, let's go to slide 19, please, to make trainings in artificial intelligence way faster. Probably you all know, because well, we are talking about artificial intelligence, but a training is just the creation of one algorithm that will be able to do whatever we have trained him to do. In this case, we are going to be able to train one algorithm with our servers and this solution up to 4 times faster than a regular x86 server with the same GPUs could. And speed is something really good in this industry, but it's not everything. Let's go to slide number 20, please. At least in the healthcare industry, it's very important to work with images, and working with images can be really something really heavy because they weigh a lot. They are very big files, and we need a lot of memory to store them. And also, it's very important to have the best resolution. For example, those in healthcare, when they are one doctor is looking for a tumor, it takes some photographs inside your body with special equipment, and the better resolution those images have, the better the doctor can see if there is something wrong inside of you. So this is exactly the same. We are going to be able to train our models with images which are between 5 and 10 times more resolution against what we could do with one regular x86 server. Just imagine that your doctor has big glasses, and he's going to look at you, and he suddenly gets rid of the glasses. You wouldn't be very happy because it could see almost nothing. Well, this is exactly the same. The more resolution those images have, the better the training is. And this is huge for the healthcare industry. Let's go, please, to the next slide, slide 21, which is just 4 links, because I think this is a really good solution, and I wanted to let you to give you some links in case you are interested or you are in this industry, because I think it can help save lives, really. Let's go to slide 22, please. In slide 22, we have the distributed deep learning. And if you remember, in the original diagram, we had one Mellanox adapter, InfiniBand, which was linked to both sockets, and they were for changing. It was used for exchanging data from our memory to the memory of another nodes in the same supercomputer. Well, distributed deep learning is one solution created by IBM Research, which is very similar, in case any of you already know it, as a Horobot from Uber. Well, but anyway, this solution, distributed deep learning, is going to allow us to bypass the limits of one server. I will try to explain. When we are training one model in artificial intelligence, we are confined to the resources of one server. However, if we want If we need more resources, we cannot use them because they are in another servers. Well, with this solution, with distributed deep learning, we are going to be able to use the resources of several servers or several nodes as if they were in just one. So it's very good for parallel computing. Let's go to slide number 23, please. And this allows us to see exactly what's the advantage of using it. In the left, you can see one column, one blue column, showing one Microsoft training, which was world record at the time. And the training of this neural network lasted 16 days, which is not so much in some cases. But it was restricted to just one system, and it could not bypass the boundaries of one system. By using distributed deep learning, which is something that, I repeat, it was created by IBM Research, we were able to use 64 systems, allowing us to reduce the time from 16 days to 7 hours. And this is really, really, really good because, well, the time difference, it's incredible. But for those of you who are in the IT industry and you know more about parallel computing, let me explain you what you can see at the right of this slide. You can see one small box showing that going from 4 GPUs in one system to 256 GPUs in 64 systems, we were able to achieve a 95% of efficiency. This tells us that this software in 64 systems only lost 5% of the efficiency. And this is very, very good. Well, this is just one for the geeks inside of you. Anyway, let's go to slide 24, please. And now we are going to talk about something also. We have been talking about distributed deep learning, large memory support, and mainly they are deep learning solutions. Not only, but they are mainly deep learning solutions. However, in the artificial intelligence world, we have several other. Oh, sorry. Well, okay, so well, we have other approaches to attacking some problems. For example, logistic regressions, linear regressions, decision trees, random forest. We have several other ways of attacking those problems that we face. And all those ways of attacking the problems share one characteristic, and is that those machine learning solutions are always run in CPUs with C. And we have seen that deep learning, it never works in CPUs anymore because it's horribly slow. So we have to run it in GPUs. And using SnapML is a framework which is API compatible with other ones that we use regularly, so we don't have to change anything. But it allows us to move the workload from being executed in the CPU to being executed in the GPU. So it allows us to speed up those workloads from 2 to 4 times. And this is a game changer because it's huge. And in order for you to see how good all those 3 solutions are, we will go to slide number 25. In slide 25, you can see how we combined all those 3 solutions, SnapML, distributed deep learning, and large memory support, to make a bet against Google. We approached Google and we told them, hey, we bet you that we can make a training way faster than you can do. We will use our tools and you will use your tools. So Google decided to take 89 servers from Google Cloud to make this training, and we just took 4 servers against 89. However, the trick is that we were using all those three combined methods, SnapML, DDL, and LMS. Well, we were able to reduce the training time from 70 minutes to less than 2 minutes. This is almost 50 times faster. Obviously, this is what I call a poster-like training. It's very, very good, and it's probably the best we can achieve with this type of trainings. But it's just a reminder that things cannot be taken for granted, and sometimes things can be speed up a lot by using the right tools. And in this case, the right tools were our tools. With this, let's go to slide number 26, okay? And this is just a collection of 4 or 5 slides, which I think make a summary of what we have seen and add some points of view that probably I were not able to share before or just forgot to do it. So let's go to 27. This shows the evolution of the power processors, because, and with this, yes, I wanted to say that we have been in this industry for a long time. We have been working with power architecture for a whole lot of years. We have a huge family of Power 9 processors, and hopefully this year we will present Power 10. We are using today Power 9. Sorry. And we have already Power 11 in the labs. So it's something that we are going to be in this industry for a long time. Let's go for the next one, 28. Also, something shocking for some people is that our hardware is 100% open source. It's based in the works of the Open Power Foundation, one foundation that has been moved under the Linux Foundation umbrella. So the same ones who lead the Linux development also somehow lead the power development. And this is something really important, because we have to be able to create stacks of fully open source computing, from hardware to software to everything. And it's very important, at least here in Europe, is very much appreciated by the public sector. And lately also the private sector is also starting to make it very important for them. Let's go to slide 29. And this is one example also of another characteristic of our solutions. They are very, and I cannot stop saying very secure. If you compare, for example, our hypervisor, which is some kind of competitor to VMware, our hypervisor in more than 20 years of existence has only been found one hypothetical security breach. However, in the rest of the industry, well, the picture is not so good. So let's leave them alone so they can work more in their security. Let's go to slide 30, please. And here, I just want to say that, well, artificial intelligence has two completely differentiated sides. In one side, it's the training of the models, but very, very important is the inference of the models. Because people try to think that, well, yeah, training is important, but once it has been trained, you can deploy it in any computer. Well, in theory, that's true, but most of the times when you are using real world models, you will need appropriate hardware. You will need one hardware for the inference phase, which is way more powerful than what a regular phone or computer without GPU can do. We have solutions for the whole spectrum of the IT. In slide 31, I have another set of characteristics, which I will leave it because I don't want to to last too much time in the presentation, because I think that we have taken too much with the technical problems of the first part. We will go to slide 32, and I will very fast will talk about the software solutions in this world. Because IBM, you know that IBM is working together with Red Hat now. So IBM is adopting something which Red Hat created, something called Red Hat OpenShift, which is like one hypervisor for containers. Just for those of you who don't know it, the containers are like bubbles, and those bubbles have applications inside of them. And you can create and destroy those bubbles whenever you want, allowing us to create very, very powerful solutions. In slide 33, we will see how IBM is creating different sets of containers for different industries. And in today's presentation, I wanted to highlight one set called Cloud Pak for Data. This is one set of tools, a huge amount of tools, that can be used for artificial intelligence workloads, for creating them, for managing them. Well, I will try to show it now. This set, let's go to 34, please. This set of software has a huge amount of pieces. It has DB2 warehouse, it has data virtualization, DB2 event store, IBM streams, well, a huge amount of software components, as you can see. So let's go to next slide. Also, another very important characteristic is that it can take a lot of, it can take data from a lot of data sources, very important. And even in slide 36, we can see how one of the most well-known ERPs in the world can be used also as data source. I'm trying to be very fast here so we can have time to show you the tool. Also, in 37, slide 37, you see how this set of tools can be used to provide solution for the whole life cycle of one artificial intelligence workload. Okay. And without further ado, let's go to slide 39, which would be the IBM Cloud Pak for Data demo. And here I will have to share my screen. And I don't know if I am going to be able to do it. Let me see if I can. Okay, give me 30 seconds. I'm going to try to share my screen.
Yes,
okay?
Yes, I have given you the presenter. Now you can share the screen, sir.
Yeah, the problem is that my computer is today very slow. Sorry, and it's having some. Just give me between 30 seconds and 1 minute. I'll be back now. Sorry, I think I'm still facing the same problems as before. I'm completely unable.
Shall I share the screen, sir?
Sorry?
Shall I share the screen?
Yes, please try.
Yeah, okay,
maybe,
sir. Yeah.
Maybe the application will react somehow. Problem is that my application hangs when I try to share anything. I don't know if it's because of my computer or the resolution or? I cannot. I'm afraid I cannot share anything. However, in the deck of slides, starting in slide 40, maybe Ganesan, you can share. Sorry, I cannot see anything in my computer. I don't know if you're sharing anything or not, but maybe you can share starting with slide 40.
Yeah.
Well,
Under what I'm saying is, let's you just walk through, the slide deck and then close the session. Or you can just talk about the demo. And what I'll do is later on, I'll share the videos to them. I already captured the video in another conference. Thank you.
Okay, perfect. Yes. So, well, starting in slide 40, then we can see this set of tools is a very easy to use solution, meaning that it can be used not only by data scientists, which is something they can use, of course, but also from, for example, healthcare industry professionals who are not so skilled in artificial intelligence. This allows us to create at least starting points for the projects of artificial intelligence. And as you can see in slide 40, in the window in the left, you can see that it's a web-based solution. It can be accessed very easily using just one browser. And this solution is running inside one Power 9 server. Okay, this server has this is a small server and it has 160 threads, like 160 processors. Okay, in terms of IBM, this is small for us. So you have just to log in using your credentials, so you can be anywhere in the world. And this is something very important because this tool can be shared by extended teams that can be in India, in the US, in UK, in Europe, wherever they are. And this solution then takes you to the next window, okay, the black one. Here, below overview, you have several projects that you can be working on. And in this case, I selected one project. Well, you will be able to see it in the video, probably. And let's go to slide 41. And I used, for this project, one small file that I uploaded from my computer. This file is just like one Excel file. It's a very small one. And it has, it's what we are going to try to do is to create one model that will tell us if somebody is going to develop diabetes during its life. So in order to do this, we take a big data set. Well, in this case, it's one example, so it's not so big. But in this data set, we have one native North American population example where it's just women, and it shows if they developed or not diabetes. So it has several characteristics. Let me, and those characteristics, let me make it just slightly bigger in my screen so I can read. So each of the columns shows, for example, the glucose levels, well, different body mass index of the person and different characteristics. And the last column is just one or zeros. 0 if the person didn't develop diabetes, 1 if the person developed diabetes. So taking just this Excel file, we can create what we call one auto AI experiment. This is something completely automatic that just requires the touch of 2 or 3 buttons, not more, and will allow us to by using artificial intelligence, select which is the most interesting artificial intelligence method to find what we want to find. In this case, which is the screen on the right side, you will see in the bottom several methods. Gradient boosting classifier with several features and enhancements. Well, with this, taking the one with the best accuracy, for example, because we can select accuracy F1 or whatever characteristic we think it's better to define it as the best. And we can then do several things, okay? This is something, this process just selects the best method to find the trained algorithm. So let's go to slide 42. Once it has ended, we can find the model evaluation with different characteristics like accuracy, precision, recall, F1, whatever, okay? Something which is very valuable for the data scientists to be able to evaluate this solution. At the right, we also can see something called a notebook. So the tool creates automatically a notebook allowing us to see how it has developed this method. And it's very important because in artificial intelligence, one of the most important things today is accountability. And this allows us to create accountability. Let's go to slide 43. In slide 43, we can see that also, apart from the accountability, we can create, we can put this solution into production directly, just by using 2 or 3 buttons more, and you will be able to see it in the video. Sorry for not being able to do it today. You will see how we can put it into production, and the same server that allows us to create this method and this trained algorithm will put it into production and will give us the necessary code to be used immediately from any computer in the world. So once we have this trained method, we can access it. And at the right side of this slide, you can see one example because we can we can make a test online. For example, was giving the method the different parameters that we had in the Excel file. For example, the number of people that has the number of people, the number of pregnancies that this person has had, the glucose levels, exactly all the same columns. At the end, we press the button in the bottom, the blue button, and it will show us the output. In this output, it will say 0 or 1. 0 if it thinks it will not develop diabetes, 1 if it will develop diabetes, and also the precision of this of this test. And I forgot to say that apart from this online, of course, you can access all those methods placed in production by using Python. You can use JavaScript, you can use Java, curl, almost anything that is used today. And this would be the end of this presentation. Sorry again for all the technical difficulties I have had today. and hopefully you will enjoy watching the video later on. Thank you very much.
Thank you, sir. That was a very informative session. Thanks a lot for taking your time to share all this with us. We appreciate your efforts, sir. Thank you so much. And with that, we come to the most awaited moment of the day. Yes, it's time to announce the best paper. May I call upon Mr. Ganeshan Narayanaswamy from IBM to do the honors.
Sure. Good evening to all. I hope you enjoyed the presentation from a colleague who spent nearly 45 minutes explaining about AI and its features and how this could be used in industries. And that's very important for you to understand that. And I do have a some kind of the basic AI information also. Later I'll share it with your organizer so that they can share it with you. But in this time, we all should learn about the AI, data science, ML, DL. It's very important for all of us. And take your time later, and go ahead and study about AI. And now, coming back to the the conference, the last moment, the best paper award. So the best paper from CSE department is awarded to Universal Remote Control with the paper ID CS210925 by Mr. Venu Dattatheriya Vemuru from RMK Engineering College, Chennai. Congratulations, Mr. Venu, for the award.
Thank you, sir.
Okay, thank you for your contribution too. I really appreciate it. And let's move on to the second the paper award. There are two best papers from ECE department. The first paper is analyzing the Grover's algorithm in IBM quantum computers with the paper ID EC210929 by Mohammad Wasif R and Dr. Ashokan from Government College of Engineering, Tanjore. The second paper in ECE is classification of cervix type colposcopy images using deep learning with the paper ID EC210964. Mrs. N. Tendral and Dr. D. Lakshmi and Dr. Senthil Kumar from Meenakshi College of Engineering and St. Joseph College of Engineering, Chennai. Thank you for the team, for getting that, the best paper awards in quantum computing and deep learning. Really appreciate it. Thank you, and congratulations to you all.
Thank you, sir.
And let's move on to the fourth, the paper winner. We have the best paper from EEE department, Intelligent Industrial Automation using IoT. Paper ID EE210907 by DK Sudhir Ammapalai. Oh, sorry, I'm actually trying to. Okay, Ammapalai Doronakaredi. Sorry for mispronouncing your name, but anyway, I couldn't make it. From SV College of Engineering, Tirupati, Andhra Pradesh. Congratulations to the team, for the the best award from IoT.
Thank you so much, sir.
And thank you. Yeah, and the best paper from Department of IT, Automatic Information Retrieval System using number plate detection. Paper ID IT 210903 by Miss M. Kavya and Miss R. Dharani Priya from Meenakshi Sundararajan Engineering College, Chennai. Congratulations to the team for getting the paper award, from the Department of Information Technology related to automatic information retrieval system using number plate detection. Congratulations again to the team. And let's move on to the last one. The best paper from the Department of Mechanical Engineering. Portable air pollution control system, paper ID ME 210904 by Mr. Praveen Kumar V from Panimalar Engineering College, Chennai. Congratulations,
So
Praveen Kumar, for the paper
thank you so
award. Really
thank you
appreciate
so
it. Yep, I think it looks like you all did a wonderful job on getting into IBM quantum computing and the automation and pollution control and IoT deep learning. Oh, this is actually a very wonderful thing. Probably we maybe I will invite all of you whoever award is can get together and have a discussion about what we can do with the IBM supercomputers, whatever Mr. Ander spoke about and all the stuff. With this, let me close here. And organizer, please proceed.
Thank you, sir. Congratulations to all those whose papers have stood out from the rest. And with that, we come to the end of this session. I would like to quote the words of James Allen. No duty is more urgent than that of returning thanks. To thank each one of you who have made this event successful, I call upon Dr. L. Nalini Joseph, Vice Principal of Loyola Institute of Technology.
Thank you, Angeline.
Ma'am, we could not hear you, ma'am. You are under mute.
Good evening. Today, a blessed day and a great technical day where lots and lots of ideas, exchange of technical jargons, expertise in the edge technology, AI in Industry 4.0 was showcased in this international conference organized by Loyola Institute of Technology in association with Open Source IBM. Respected Founder Chairman, Reverend Father J.E. Arulraj, Management Trustees, Correspondent Sister, Admin Sister, beloved Principal, our most distinguished invited speaker, eminent session chairs. Ladies and gentlemen, it's my privilege to propose a vote of thanks on this great occasion. I'm Dr. Nalini Joseph, Vice Principal and Coordinator of this conference. Fear of God is the beginning of wisdom. Let us give glory to God for the resounding success of this international conference. Our sincere, heartfelt thanks to the Loyola Institute of Technology Management for providing the opportunity for accomplishment of our college vision and mission to train our students and produce them as a world-class engineers. Thank you, Reverend Father and Reverend Sisters. Our hearty thanks goes to the correspondent sister and the admin sister, the best support in all our activities. Thank you, sisters. Our sincere thanks and appreciation goes to our associative partner, IBM, and Mr. Ganesan Narayanaswamy, Open Power Leader in Education and Research, IBM Systems, for his best support in identifying the eminent international speaker and marked his support in a remarkable way from the day one till today and years together. Thank you, Mr. Ganesan. We're extremely grateful to the keynote speaker, Mr. Ander Okyogilo, Cognitive Computer Architect and Team Leader, IBM Europe, for sharing his technical expertise in this conference. Really, your talk would have given different perspectives in different IBM services and solutions and the best practices of AI in Industry 4.0 globally. Thank you, Mr. Ander. Our special thanks goes both to the international and national advisory committee members for their guideship and the remarkable support in each and every stage of this conference. Their advisors helps us to conduct this conference in a procedural way. Thank you, advisory committee members. I'm in search of the best adjective and an adverb to share my thanks to our beloved principal, Dr. Sujata Anand, the organizing chair, who have planned and lead us to conduct this international conference with our enriched global standards. Ma'am, your tireless effort in planning and execution had borne fruits in the best way. Thanks is a small word, ma'am, but we all say with heartfulness. Thank you, ma'am. The success of this conference goes with appreciation and thank note to all the session chair of various departments. We are greatly bounded to the following versatile session chairs. Mr. Dhyaneshwaran, IT Management Professional in Public Health Organization, Singapore, as Session Chair in the Department of ECE. Professor Ratina Kumar, Department of Information and Communication, Dong S University, South Korea, as Session Chair in the Department of CSE. Mr. Edson Frandler, Product Engineering and DevSecOps, K10 AI, Chennai, as Session Chair in the Department of IT. Dr. Belsam Jeba Anand, Associate Professor, Department of Mechatronics, SRM University, Chennai, as Session Chair in the Department of EEE. Mr. Satish Shagur Ahmad, Senior Pipeline Engineer, ADNOC Onshore, Abu Dhabi, as Session Chair in the Department of Mechanical. You all supported us in spite of your busy schedule and different time zones. You shoulder our responsibilities in evaluating and validating all the papers throughout the day with your keynote address and tips and expertise to the participants. Thank you, session chairs. May I take this time to extend my appreciation to all the participating faculty members and the students of various institutions and industry personalities. Your active participation to showcase your talents and realize your potential. You had a big platform today. Yes, in this pandemic, nothing can stop learning or gaining of knowledge. You are exhibits of it. Thank you, participants. Last but not the least, I sincerely thank our team, the pillars of this conference, the members of all the organizing teams, our faculty members, and our students who have worked meticulously, tirelessly for this international virtual conference. We have achieved it successfully. Thank you, Team Loyola. Once again, on behalf of our team, I extend a cheerful thanks to everyone who helped us directly and indirectly, and all our professional friends who made this international virtual conference on emerging trends on AI in Industry 4.0, organized by Loyola Institute of Technology in association with Open Power IBM, a grand success. I conclude. Stay safe, stay home, and keep social distancing to overcome this pandemic. We all meet you next year, same time, with different title. Until then, we are signing off. Thank you all. Over to Angeline.
Thank you, ma'am. Dear participants, a feedback link will be posted in your chat box. Please fill it and submit it. Thank you, Mr. Ander, for sharing valuable information with us, and thank you, dear participants.
And thank you very much, Angel. You took the evening very light and well. And once again, thank you, Mr. Ganesh. Without you, this day would have just not been possible. And Mr. Ander, you are awesome. Thank you very much for all your valuable time. And Team Loyola, wonderful coordination under the able leadership of Mrs. Indumati and Mrs. Kumuda. Thank you very much.
Thank you so much, ma'am.